Today we are going to talk about probability. Probability is the likelihood that an event will occur. So to kind of measure that, we've got this probability scale. We start our probability scale at 0, just like you would a number line, okay? So we start at 0, otherwise known as 0%, and it goes all the way to 1. Okay, so the highest likelihood would be a value of 1. The lowest would be a value of 0. Now we can convert those to percentages if we would like. We can say a 0% chance or a 100% chance. Now, if we have a 0% chance, a 0 as our likelihood, that means that the event is impossible. It is not possible for this event to occur. On the other side, we have certain. If something has a likelihood of 100%, that means that there is no doubt that this event will occur. It is certain. Okay. So you've got 0 on the low end, 1 as the high end, and in the middle, we've got our half, our 50%. This is your even chance. It has an even chance of happening. It has an even chance of not happening. It's an equal chance on either end. Okay, so that would be your 50% chance. Down here, in between that 0 and that 50%, we've got unlikely. As a marker, we've got that 25%, 1/4. But everything over here is considered unlikely. And the reason for that is it's not impossible, right? There is a chance that it could happen, but it's not an equal chance. Okay, so everything in here is unlikely with kind of that marker as 25%. And that means everything above 50%, all the way right up to that 100%, is likely. Again, anything that falls over here, it's not certain, it's not 100%, but it's more than 50%. So that event is likely, again, with that 75% marker. Okay, so we use this scale, impossible, unlikely, even chance, likely, and certain, to kind of determine the probability or the likelihood of an event occurring. So a quick example here is marbles. If these are our set of marbles, we're talking about the likelihood that we will pull a yellow marble. In this situation right here, where I have all red marbles, it is impossible. There is a 0% chance that I will pull a yellow out of this set of marbles. If we move over here, we've got 3 red, so that is more likely to happen to pull a red, whereas that yellow, it's possible. It's definitely possible. It's not impossible, but it probably won't. Pulling the yellow in that group is more unlikely. Here we've got 2 red, 2 yellow, so we have an exactly equal chance. I might pull a red, I might pull a yellow. It's about 50-50 chance that I would pull that yellow. Here I have 3 yellows and only 1 red, so that shifts to being that I likely will pull a yellow. It is more likely that I will pull a yellow than a red. And then lastly, when I only have yellow marbles, then I will certainly, for sure, always pull a yellow. So to find our probability, we use this formula here, and that is P, and then in parentheses, you'll write your event. So P stands for probability. In parentheses, you'll write what your event is. And then you'll have number of favorable outcomes. So count every favorable outcome. And then divide it by the possible outcomes. So here it says we've got this number queued. You have your die. And what is the probability of rolling an odd number? Well, on a 6-sided die, there are 6 numbers, 1, 2, 3, 4, 5, 6. And 3 of those are odd. 1, 3, and 5. Therefore, you write P for probability. The probability of an odd outcome is 3 odd numbers out of a total of 6 possible numbers. We simplify that down to 1/2. We can translate that into a percent, which is 50%. Therefore, the probability of rolling an odd number is 50% chance or an equal chance. Okay, so let's go ahead and try with some marbles. Okay, so we have a set of marbles here, and it asks us, what is the probability that you choose a red marble? So I go ahead and start by writing P for probability, and my event is a red marble. Now the total number of favorable outcomes, I have 1 red, 2 red. Because I have 2 red and then a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes, that goes on the bottom. So however many red there are goes on top, and the total number of possible outcomes is on the bottom. Again, I can translate that into a percentage, which would get me 20%. Therefore, if we look back at our scale, that falls in that lower half. So this is an unlikely event. Okay, so I have a 20% chance of pulling a red randomly. This is an unlikely chance. All right, let's look at the second one. It says, what probability that you choose not a blue? So I will write my P for probability. Again, I write and set up my formula every single time. Not blue. Okay, so I have to look and I have to count which ones are not blue here. So I've got 1, 2, 3, 4, 5, 6, 7, 8 favorable outcomes. 8 are not blue, and my total possible outcomes is still 10. That translates to 80%. That falls in the upper half, in between 50% and 100%. So this is a likely event. Now, I will have an 80% chance of not choosing blue. This is a likely event. All right, 2 more. We've got, what is the probability that you choose a yellow marble? So again, I set up my P and my event, which is yellow. I count. Yellow is my favorable outcome. So I count. I have 1, 2, 3, 4 yellow. Possible outcomes is still 10. That leaves me with 40%, which is unlikely. Okay, so I have a 40% chance of pulling a yellow. This is unlikely, an unlikely event. Last problem, what is the probability that you choose an orange marble? So again, I set it up, P orange, the probability of an orange, and I look, I have 0 orange marbles, so I need to write 0 favorable outcomes out of a possible 10. That moves to 0%, which is impossible. With this set of marbles, I have a 0% chance of pulling an orange, making pulling an orange impossible. So we use our scale, we use our formula, we set up our problem, count our favorable outcomes and our possible outcomes, find our percentage, or fraction works as well, and then I determine, using my probability scale, how likely it is or unlikely it is for an event to occur.